Hello everyone, welcome to this video. And in this video, we are going to implement a simple visual question answering program in the PyTorch framework. So let's get started. So first of all, we are going to take a look at the dataset. The dataset is Easy VQA, which is one of the simple and easy dataset if you are new to visual question answering. So it contains two folders, test and train, and each folder contain images and the question associated with it. Here you can see simple images. These are really simple images and with simple questions which are inside this JSON file. So here you can see each data point would contain a question, its answer and the image ID. This 0 indicate the name of the image without extension. So this is how it is. And the same structure is going to be in the train folder. Same images and then question. Just that the train would contain 4000 images and the test would contain 1000 images. And this is the answers.txt file. So it contains all the possible answer which any question can have. So it's a multiple choice question answer system, you can say, or technically we can also say it's an image classification kind of problem where we just have two input. One would be image, another is a question. So it's a classification type problem. You give two input and based on those input and their features, the deep neural network need to classify or select the best answer. So this is how it would work. Now we would work on the data set first. We'll write the code for its processing, and next we would have the split, that is training, validation and testing part. So we'll split the training into two part, training and for validation. So let's work on that. So first of all, I'm going to copy all the libraries and functionalities which we require. And here if you see, the important function is train test split. We're going to use this to split our training data into two parts. Next, let's start with the main function first. We'll define the main function. Okay, here is our path to the data set. Next, we would implement a function called get data. So this get data function would take two arguments. First would be the path, and second it would say whether it's the train data or the test data, both of these. Because based on this we're going to load this, whether it is, if its train is true we're going to load the train data, if it is false we're going to load the test data. So now we're going to work upon this get data set function. So let's implement it. So let me directly copy it, because writing takes a lot of time and I feel this is much better way. I'll just copy paste the code and explain to you. So this is the function. So first of all we'll see what kind of data it is. If train is true, then the data type is train, else it is test. Okay, next we're going to load the JSON file, these questions.json, based on the data type, whether it is train or test. So let's load the JSON file. So here you can see the complete path. Let me zoom out a bit. Yeah, so first is dataset path. This, let me, yeah, this data, then data type, whether it is train or test. Here out of one would be select, and inside those we have one file which is common, that is questions.json, and we're going to read that file and dump all the data. So let me print the data here and show you, and this would be data.py. Okay, so why it is not working then? If we have load the data, we have everything, it should work. Print data, it's fine. Yeah, one mistake is that I haven't called this main function now. This is the issue, right? I'm thinking why it is not working, what could be the possible error, and this is the possible error, just that I haven't called it. Okay, you can see a lot of data. Let's go to last. You can see a list. It is a list of list. The list contain list, and inside each list it would have these items. First would be question, then the answer, and then the image ID. So we're gonna work like this, and next we're gonna load the question, answer, and the image path. So this is question, then answer, and then the image ID, which we're gonna convert into a proper image path so that we can load that image later. And remember, all the images here are resized to a size of 64 by 64. So they are really good in itself because you don't need to pre-process them or do anything resizing or that thing. So they are properly resized. Let's get back to code now. First of all, we're gonna have empty list of question, answer, and image path. These are empty list, and inside each of which we're gonna add our data. So here we have this data, and we iterate over it, and with each iteration we would have a list. You see this list, and within each list we would have Q, A, and P, question, answer, and the path, or you can say the ID or name. Let me print them for you. Q, A, and P, and I'll break it because otherwise it would run. You can see the question, what is the blue shape, rectangle, and 0. Now it is from the train part, I'll show you this. Let me open the train images, and name is 0. Yeah, 0. Let's open. You can see the 0. So this is the image. Okay, fine. So we are fine with this. Now what we need to simply do is append. For question and answer, it's really easy. We can easily append them because we don't need to do anything. But for this P, the image name or the ID, we need to make it a complete path. So I'll show you how it is done. So we have images path dot append. Inside we have this os dot path. So we create a complete path. So first is this dataset path, which is data, then data type, and inside that we have images. Because the structure and naming of the folders is same both in test and train folder, so it would work for both. We have images, then ID, and then we say PNG because all images are PNG, so it's no issue. So this is how it would work, and we're gonna get back question, answer, and image part. So the first part is done. We have loaded the training data and the test. Now if you remember, we have one more file, this answers.txt. So it contains all the possible answers, so we need to load that also. So it's a JSON file, so it would be easy to load. So here's the function to get those all answers, or we can say the labels, the possible answers. So this is really simple function. I don't think I need to explain it to you in great detail. So I'll show you unique answers. Yeah, you can see circle green, red, gray, yes, teal, and all the possible answers. So our model need to find which one of them suit the best according to the context of the image. So this is done. Now we need to split the training data into training and validation. So it would be 80-20 split. 80% would be for used for training, and remaining 20% would be used for validation. So let's do it. It's really simple in itself, no unnecessary things. So here we have train test split function. We give it training question, training answer, and training images. We say test equals to 0.2, so 20% would be used for validation, and random state 42. Here we have the data splitted into both training and validation. Now we're gonna print how many data point we have in each training, valid, and test. Let's do it. So this part is done. that is the data processing, and we ultimately get our sets, subsets, training, valid, and test. Now we're going to move on to the model. Here we're going to implement a simple VQA, which is really simple to understand, not that complex. First of all, let's import the torch library. First, we're going to define the subclass of this anecdote module base class. Okay, so in this class takes image shape, and it would be 64 by 64 vocab size, and that we would determine after when we work on the training part. After that, we have number of answers. So number of answers, I think, should be 13 in count here. So length of this list would be number of answers. First would be the CNN part. Okay, so this network would process your image, that is 64 by 64. It's a really simple network with few convolution layer, ReLU, and max pool layer. You can see we have first convolution layer with 8 as the number of output feature channel, 3 as the input feature channel, because that image would be RGB. Next, it is followed by ReLU, then a max pool to decrease the feature map by a factor of 2, and then this sequence goes on, and at last we have a flatten layer. Then it is followed by a linear layer. So those spatial features would convert it into a more short representation, which can be easily fused with the text or the question feature. And after that, it is followed by 10H activation function. So what 10H activation does is it convert any number, any integer into the range of -1 and +1. Next, we have the question sub network, which processes your question. Okay, so here the input to your question would be of size vocab. Okay, so here we're going to use bag of words. So it would be something like the length of, for each question, it would be a specific length, and that length is vocab size. So here, just that in bag of word, what happen is the we indicate how many time a word occur. It does have its limitation, but for this simple VQA, I think bag of word are enough. We have two linear layers, each having a 10H activation function. Now we have both the feature image features and the question features. We're going to combine them. So first of all, let's have a forward layer. In this part, we have just defined the networks, the layers, and here in the forward part, we're going to run them. Here you can see the image features we get from the CNN network. We give it the image, and the question feature we get from this question MLP, and we give it the question. Now we're going to combine them. We multiply them. We simply do a multiplication, and what you can also do is you can concatenate them, you can add them, you can do a whole lot of combination, because the good part of deep learning is that it learn. So it would also learn to convert these combined feature into an answer and to get things work automatically. If you even concatenate them, it would work, because here our goal is to run it, not to get a state of the art performance. So when you need the state of the art performance, you need to work upon carefully how we're going to combine those features. Do we need to add any attention or self attention, or should we concatenate them and then add attention? So whole lot of thing is there, but for this tutorial you don't need that capability. You don't need to work upon that thing. You don't need to go into that depth. Just one simple way is multiply both the features. That's it. Next, we're going to have another set of layers which is going to process this combined feature, which is going to be a linear layer followed by a softmax. You can see now we're going to have our output via this combined network. So we have our output. Now let's run this network and check if it works properly. So here we have two inputs. First is image, batch size 8. It's an RGB indicating by these three channels. Size is 64 by 64, that is height and width. Next we have is the question. It's the batch size, and 27 refer to the vocab size, that is number of word in our vocabulary. So we define this model class, model object. Basically this is the class. We give it image shape, vocab size, and number of possible answers, and we give the both the input to this model object, and we get our answer, and we print the shape of the answer. So let's work upon it and see if our network works or not. Here you can see it's working perfectly fine, because till this part we just need to make sure that we give it input and it should give us some output. It should not have any error while combining feature or running any layer, saying the shapes do not match or any sort of those. While training, we're going to see the performance, and now we're going to work upon the training part. So first of all, we'll import all the library and functionalities which we require for this part. And next we're going to define a simple function called create dir. So what this function would does is it would create a folder for us. If that folder does not exist, we check if that path exists or not, and if that path does not exist, we say please create that path or folder for us, and we're going to use that folder, specific folder, to save our files and other things. Okay, let's move on to the main part first. So first of all, let's define a few things. Here we have our main function from where the execution would start. We first seed our environment to make sure that the things are reproducible, because deep neural network has a lot of randomness. So we seed the environment so that even your randomness is same. Then we have hyperparameter, image size, batch size, number of epoch, learning rate, and the path where your weight file would be saved. Next we create a folder to save our file, and next you see we load the dataset. So let's run this till now and see if this is working fine or do we need to work upon it. There might be some error. Okay, so till now this train file is working fine. Now we need to work upon this bag of word tokenizer, because that is our technique here to process our question. And bag of word is a really simple technique. I have even made a video on it. I would say please watch that video. It's a really simple implementation of bag of word without using any unnecessary library, so that you get to know what it is about. So I would not explain bag of word here in full way. I would recommend you to please watch that video which I have uploaded previously. And here we have our tokenizer. We fit it on training and validation, and this is our vocab size. So what I can do, I can print vocab size for you. It's 33. So this is about the tokenizer. Now we'll work on the dataset, data loader and everything. So let's move back and I'll paste that function and I'll explain to you. Oh, this is really long. So this is our VQA dataset, and it first take questions, then answer, image path, tokenizer, the labels, that is this answer.txt, then image height and image width. So these are all the argument which it take. Next we have this predefined function which we should define, that is number of iterations from work upon. Next, this is the main function, get item. So here it takes the index number. So it work upon each individual question, answer and image path. And we write the entire set of code to process them and give those respective outputs. So we take individual question based on the index from the question, answer and image path. So here we use our bag of word tokenizer to convert that question into a text representation, which we have seen here one way. Then we process the answer. So what we do here, we do a one hot back kind of vector thing. We have this answer index, answer one hot. So it's a numpy array of the length of label, that is I think 13, and then we have everything 0 in it. Then what we do, upon that index number we say equals to 1, and finally we process the image. We read it as an RGB image, we resize it. Maybe you can skip this step, but I'm using it just to be sure. If any image is not resized, it would be resized. Maybe before during the data processing you can check all the image size, but I would simply resize them. Then I divide the image pixels by 255 just to normalize the image pixels in the range of 0 and 1. Then we transpose it, because PyTorch take the RGB image as channel, then height, then width, and with the TensorFlow it's like height, width and number of channel. That's what we do. After that we convert everything into a tensor. You can say image is converted into a tensor. Then we have this question also converted to tensor. Then we have this one hot answer into a tensor. So this is how it would work. Now we have our data set and its loader. I'll paste that part here. Yeah. Next we have our model and its related things. Okay, so first of all we check if we have a CUDA device or not. If we have, it's gonna train on that, otherwise it's gonna train on a CPU. For now I'm having a 1050 Ti because my 3090 is kind of dead and is to the service center, and I hope it would be fine soon. Otherwise it would be a lot of cost for me to accommodate, but now 1050 Ti is fine for this task. So we have our model here. We give it all the arguments and we load it into our appropriate device, that is CUDA or CPU. In this case it's CUDA. Then we have our optimizer and the loss function, and here we are using cross entropy. Now it's time to write the code for training, and I'll simply copy paste this large code. It's the main function here for training. Okay, I'll simply explain it to it. So this is our function to train the model. It takes a model, then train loader, valid loader, optimizer, loss function, then your device, CUDA or CPU, number of epoch you want to train it upon, and the save path. First we have here is best validation loss, because we are using it the validation loss as the criteria to save the weight file or not. If your validation loss is decrease as compared to your best val loss, initially it is infinite. So let's say if your val loss would be some, let's say 2 point something, then it 2 point something is less than infinite float, so it's going to save the weight file. Then in second iteration, if the val loss is like 1 point something, so it's going to save because it is less than this. If it increase, the weight file is not saved because we need the best weight file. First we start with a iteration, with a loop with number of epochs at the number of time it would run. We set the model to train. We have two variables set to 0, train loss and train correct. Then we iterate over the train loader. It's going to give us batch of images, question, answer. We put them into the GPU. We set the optimizer gradients to 0. Then we give the model images and question, and we get the output. We give both the predicted output and the correct answer to the loss function. We get the loss value. We do backward propagation and whole lot of thing here, and then we have our, then here we calculate the total loss. Just we add this loss, and later we calculate the total loss. Then here we calculate the number of correct answers just to calculate the accuracy, and here we calculate the training accuracy. And same thing we do for the validation, but here we set the model to eval, because during training it's going to update the weight, but during validation it does not update the weight. That's why we say model.eval. And here we additionally say model with torch dot no grad. Basically it says do not update the gradient, update the weight based on the gradient, something like that. I initially even I don't know what this means, but I know its functionality where it is used. Again we load the image, question and answer. We load them to the CUDA device. We get our output. We get the loss function. We add this into the val loss. We have the correct answers, and we get the validation accuracy here. And here we print everything. What the epoch is, it is train loss, train accuracy, val loss, val accuracy. And here we have the criteria to save the weight file. If your val loss is less than your best val loss, we will update the best val loss and we save the weight file. So this is how it works. Really simple function, not that much to explain. And what I'm going to do, I'm going to simply call that function here, and we're going to start our training. Let's see if it work or it does have any error. Because error is a part of your life when you write code, and diagnosis and debugging them, not diagnosis. Debugging them is also a part. So here you can see it's training really fast. It does not take that much time. So that is the advantage of using an easy and simple data set for any task. If you are new, and if you have experience with that task, you can use any good data set to optimize things. You can see we have training loss, training accuracy, val loss and val accuracy. You see it's improving. So what I've done, I've trained the model for few epochs before that, and I hope you understand that my GPU is not that great, so I haven't done that much work. So what I'll do, I'll simply replace the files. Yeah, I've replaced the files. There is the weight, and I've also calculated confusion matrix in the test file. So let's now work upon the test file, yeah, where we're going to calculate its performance. So I'll import all the things. Then we're going to have our main function. I'll copy most of the thing because they are nearly same. So first of all, we're going to seed the environment to make sure it is reproducible for you also. Then we have hyperparameters. Then we have data processing, where we get the data, split it. Then we have bag of word tokenizer. Okay. And here with this, we convert all the text question into the text representation. And here we load our model and set it to model.eval, because here we need to test it. We are not going to do training here, so we set it to model.eval. Let's call the main function and check how it is still now. Okay, so it's fine till now, everything is working. Now we need to work upon things after that. Okay, so now what we do, we gonna iterate over our test set here. Okay. Let me write the complete code here. So here, if you see, we have first of all two empty list, train value and pred value. So we're going to save both these, true value and the predicted value, which we're going to use at the end of this code to calculate performance various metrics. After that, we iterate over the test question, answer, and the image path. So here this question answer would contain individual item. First, we convert the question into a tensor because it is already converted into a numeric representation using this bag of word function. Then we have answer. We have the index number here, not the one hot representation, just the answer. We append it to the true value. Then we have image. We process it same as we have done during the training. And if I show you, just let me, yeah, here, same as this part. And then we do prediction. We give it image and question. We get the pred contain the predicted index value, and we append it to the pred value list. So this is how it would work. So now after this iteration, this loop is done. We have both the true value and the pred value, and we're going to use those lists to calculate various matrices. And let me copy that part of code also. Yeah, so first of all, we do a classification report using true value, pred value. The target name would be unique answers, and zero deviation is 0. Then we have a confusion matrix, and we're going to save it. Okay, so let's run this part. Okay, so it's running, and here you can see the classification report. So here we can see an accuracy of 23%, and that is because you need to train it more. Now we'll see the confusion matrix. This is the updated confusion matrix. You can see in a form of a heat map, and it indicate most of your problem lies with yes or no, major of them. I hope you learned something from this video, and if you are new to this visual question answering, and I hope this video would be useful to you. So that's the end part, and I hope you enjoyed it. So please make sure you like the video, share it with your friend or on your social media, and subscribe the channel for more such informative tutorial. Till then, have a nice day. Thank you.